Hello. Today we are going to be doing a home experiment on cellular respiration. And in that experiment, I am going to be following along with our lab sheet and doing the procedure. When we do this home experiment, we are going to be using yeast in order to collect the gas, the gas after cellular respiration. And we're going to show how yeast produces that gas in order to produce energy in cellular respiration. Okay. On our lab sheet, it asks for the following materials. If you want to do this with me at home, that's fine. You can do it with me at home, or you could possibly do it later. You could also simply watch and gather this data and watch as we collect the gas inside our balloon to see cellular respiration happen. So our materials are dry yeast, which is a unicellular organism, and it needs activated, and we're going to activate it. We need a bottle, we need a balloon, we need sugar, some warm water, which I've been monitoring the temperature of, and therefore I have pulled out my thermometer for it. Okay. We need masking tape, a tape measure, and with the tape measure we're asked to measure in centimeters, so I'm going to be using the centimeter side of my tape measure. And I have also pulled something to time with, because we need to track this over 8 minutes. A funnel. I pulled a funnel in order to place the items into my bottle, and I also pulled a measuring spoon. Okay, so let's get started with the procedure in order to watch yeast produce a gas in cellular respiration. So our first step of our procedure asks us to put 1 spoonful, and I'm using a teaspoon. I'm just measuring it out, so I'm sure about how much I have in there. Okay. I'm going to put a teaspoon of yeast inside the bottle, and I'm just making sure that there's a full teaspoon there. Okay, a teaspoon of yeast inside the bottle, and it also asks for 2 teaspoons of sugar. So I'm going to measure 2 teaspoons of sugar into the bottle. Okay, and then it says to fill the bottle 3/4 full. Fill the bottle 3/4 full. I'm just making sure that everything's in there. Okay, okay. It says to fill the bottle 3/4 full with water that has the temperature of 75 degrees to 90 degrees Fahrenheit, and that's warm to the touch water. Okay, and I just want to monitor my temperature to make sure that it is within that range. Okay, we don't want it too hot, because if it is too hot, what happens is that it kills the yeast. Okay, and then we won't have any cellular respiration. If it's too cold, it will not activate the yeast. Okay, so I'm going to fill my cup up with a cup of water. I'm using 1 cup of water, and I'm going to again use my funnel. And I'm going to pour that water into my sugar and yeast mixture. Okay, and the sugar is in there in order to provide the energy for the yeast when it becomes activated. Okay, so our next step of our procedure says to quickly stretch our balloon over the opening of the bottle, and what I'm going to try to do is to make sure that the balloon's opening is centered over the top of the bottle, because sometimes it gets to the edge and doesn't really collect all the gases. Okay, and then we are asked to take a piece of masking tape and to secure the balloon on the bottle. Okay, and we're doing this in order to make sure that the gases don't escape. Okay, when the gases escape, then we don't collect it into the balloon, and we don't actually see what is happening inside the experiment. I'm going to turn it around and make sure that I have this edge securely taped. Okay, and I'm going to press it down so that I know it's happening. Okay, and now we have to track this for 8 minutes, so I am going to find my timer, and I'm going to start my 8-minute track toward watching this particular experiment. Okay. So while I get started with that, I'm also going to shake the bottle. The procedure does say to shake the bottle. Okay, this is yeast, so you want to be careful about it. You don't want to shake it a lot. You don't want to shake the liquid into the balloon because we want to collect the gas. Okay, but you do want to make sure that the yeast is mostly inside the warm water with the dissolved sugar, because again, the sugar provides the energy for the living organism of the yeast. Okay, and then what we get to do here is we get to wait to see. Now, I would like you to make note that the balloon is not very big. Okay, it was flat when I put it on. Okay, it was very flat when I put it on, and what we're doing is we are tracking the diameter of this. Okay, I also should make note that we should be checking the warmth of the bottle. We want to please note that in any chemical reaction, heat energy is generated. Okay, and one of the things on our observational chart is to check the warmth of the reaction. Okay, and what we're going to do is simply wait and watch while the balloon collects the gas. Okay, and while we do this, it never hurts sometimes simply to very gently swirl to make sure that everything is working and happening. Okay. Okay, now I am approaching my 2-minute mark. Okay, so I'm going to get ready for my measurement tape. And in this experiment, my daughter Emma is going to help me measure, because it's nice to have 4 hands in this. Okay, and she's going to hold it up gently without squeezing it, and I am going to measure the balloon diameter of this, and we're probably about at 9 centimeters. Okay, so I'm going to mark that down on my chart. Okay, 9 centimeters, and I'm also going to double check the warmth of the bottle. Okay, it's still very warm. It's still very, very warm. Okay, and I want to note the inside of the bottle. Please note that we have some cloudy liquid and a small layer of foam on the top. So I'm going to write down cloudy liquid. Okay, with a few bubbles on the top. Okay, and we watch and wait. Okay, Emma is loving this. She is a biochemistry major in college this year, and she is very familiar with this experiment and knows can explain what happens too. Okay, now if you can see, you can watch the balloon move. Okay, you can watch the balloon move. Okay, and I'm double checking our time. We have about 30 seconds to our next measurement. Okay, now it's 3:55, so I'm going to, for our 4-minute mark, we're going to again, I'm going to ask Emma to make sure that she's not squeezing the balloon at all, okay, because you don't want to squeeze the gas out, okay, and I'm going to take the widest part, and I'm going to measure it, okay, and I would say we're at about 12 centimeters, okay, we're at about 12 centimeters. I'm going to mark that down on my chart, and I'm going to measure I'm going to take a look at the warmth, and it's very warm. It is still warm. Okay, and because this is my hand and my touch, I can't quite measure the temperature, of course, but the warmth is staying. It's not as though it's getting cooler. Okay, now if you take a look at the layer of the foam on top of that yeast, there is quite a bit of that. Okay, that has grown, and that please note that there is a thicker layer of foam, and I'm going to put that down. That we have a thicker layer of foam on here. Okay, and just to make note as we go forward, if you have ever noticed in bread, there are bubbles in bread, and the bread itself gets these bubbles formed by the yeast. Okay, we use yeast to rise bread and baking products. And when that happens, that those bubbles form, and when you bake the bread, of course, the yeast die. However, the bubbles stay, and that's what makes your bread rise higher and higher. Okay, and as you see, we have lots of gas gathered in here. Okay, and it's really cool to watch the balloon go. Okay. And as a matter of fact, it's so upright that I probably will not necessarily need Emma's help. Okay. But it is at 6 minutes, and I'm going to measure the you know what? Maybe you might reach in here. Okay, we are at 15 centimeters. 15 centimeters, okay? I'm going to write that down. I'm going to measure oh, it's still, okay, it's still warm. I would say it is almost as warm as when we started. Okay, and take a look at the layer of that thick layer of, I would say that there is a thicker layer of foam on top of it. Okay, and as we approach our 8-minute mark, which will come soon, I just want to make note that I did set up a control bottle earlier before I started this experiment. And so this has been actually longer than 8 minutes. This has been sitting here longer than 8 minutes. And this control bottle, just so you know, is a bottle filled with the yeast and water. There is no sugar. So there is no energy in there for the yeast to use. The water was warm as it was when I put it as the other bottle. And this is a comparison right here. Okay, so this has been going on for quite a while, and please note that there is very little gas gathered in this balloon. Okay, and that gas that is gathered in this balloon, or the gas that is gathering in this balloon, is not here because there is no energy provided for the yeast inside this bottle. Okay, so there was no energy. So if we took a look at this experiment, our independent variable here would be the fact that we have sugar in this bottle and no sugar in that bottle. Okay, so we're at 8 minutes. Okay, and I am going to measure. I'm going to further measure. I'm going to measure one more time this particular, the diameter here. Okay, and we are at 16. Oh, here, wait a second. Let me get my finger out of the way. Okay. We are at, I'm going to say 16 and a half, okay? 16 and a half centimeters, okay? And that is at 16 and a half centimeters, and that is at 8 minutes, okay? Please understand that I'm feeling the warmth, and the warmth here, please note, is generated by that chemical reaction. Okay, in the cellular respiration reaction, there is a heat energy generated, and that energy is part of what is being released here, and so I'm going to put down on my chart that it is still very warm. Okay, and if you note, I will say this to you, and I know this has gone on for a little bit longer, but this is quite cool. Okay, my bottle here, my control bottle, is quite cool. It has lost energy. Okay, this one will stay warm for quite a while. And take a look at the layer of foam there. Okay, there's a very thick layer of foam. Okay, because we know what's happening is that the yeast has been activated by sugar and water, and warm water, and the yeast is feeding on the energy of the sugar, and it is releasing the waste gas, the carbon dioxide inside that balloon, and the and energy, and that is the whole purpose of cellular respiration, in order to release that energy. Okay, So I hope that this will help you to be able to, I hope that this will help you to be able to answer your analysis questions and go forward. And if you want to try this at home, it's a really cool thing to watch.